Last episode you watched an AI get a very particular set of hands, a terminal, the power to edit files and run commands. It was powerful precisely because it was narrow. Files and commands, nothing more. But now let me ask the bigger, wilder question the whole field is chasing right now. What if you did not restrict the agent to a terminal at all? What if you gave it the same interface you use? Not a special programming door into an app, but the app itself, seen on a screen, operated with a mouse and a keyboard. An AI that can open your browser, fill out a form, click through booking flow, or move files around in a folder using any program a human can use, because it is using it the exact same way a human does. That is a computer use agent, and it is one of the most ambitious and genuinely unsolved problems in AI right now. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. Here is the idea in one sentence. A computer use agent perceives a screen, usually as a screenshot, and produces the same low-level actions a person would: move the mouse to this spot, click, scroll, type these keys. Then it looks at the new screen and does it again. That is it. And I want you to notice how radical the simplicity is. Everything else in this course, when we wanted a model to reach the outside world, we gave it a clean, structured door. Function calling, an API, a tool with neat typed arguments, the model context protocol. Those are wonderful when they exist. But most of the software in the world does not offer you a tidy API. Your travel booking site, that ancient internal tool your company runs, the desktop app with no automation hooks at all. A human just looks at the screen and clicks anyway. A computer use agent is the bet that an AI can do the same, which means it can operate the enormous universe of software that was never built to be automated. No API required. Just eyes and hands. So let me take apart the loop, because it is beautiful in how simple it is, and it is exactly the reason Act Observe loop from earlier in the course wearing new clothes. It is called a perception action loop. Step 1. Perception. The agent is handed a screenshot of the current screen, and here is where everything you might have half forgotten about multimodal models pays off. A vision language model looks at that image and actually understands it. That is a text field. That is a blue submit button, and it is at roughly this position. That is a cookie banner in the way. Step 2. The reasoning we spent this bonus round building up to, given the goal, book the 9 a.m. flight, and given what is on screen right now, what is the single next action? Step 3. Action. The model outputs a concrete command: click at these coordinates, or type this text, or scroll down. That action gets executed on the real machine. And then, crucially, step 4, it takes a fresh screenshot and starts over, because the screen has now changed. A menu opened, a new page loaded, and it has to perceive the new reality before deciding the next move. See, click, look again, click again. Around and around, one small step at a time until the task is done. Now let me make the difficulty concrete, because this is where I have to be honest with you, and the honesty is the whole value here. This is hard. Much harder than it looks. There's a benchmark that measures it called OSWorld, and it is refreshingly real. Around 3069 genuine tasks across real web and desktop applications, file operations, multi-app workflows, each one starting from a fixed state and graded by a script that actually checks whether the task got done. And the scores are humbling. When the first Claude computer use model was tested on OSWorld back in 2024, it scored under 15%. A human doing those same tasks lands somewhere up around 70+%. So the early agents were failing the large majority of the time. Now, the good news, and it is real progress. The newer frontier models have climbed to roughly the low 80s on the browser-focused version of that benchmark by most reports. A massive jump in a short time. But look at what that number honestly means. Even the best of them still stumbles on a meaningful share of everyday tasks, and there is a real split in the field. Some agents, like the ones behind OpenAI's Operator and Google's browser-focused efforts, specialize in the web where they can also peek at the page's underlying structure, while others, like Claude's computer use, trade some of that browser polish for the ability to drive a full desktop, any app, not just a browser tab. Reading a screen pixel by pixel and never misclicking is just genuinely unsolved. And that brings us to the part I refuse to skip, because it is the most important thing in this episode: safety. Everywhere else in this course, when an agent made a mistake, the cost was usually a bad sentence or a wrong answer. A computer use agent that makes a mistake clicks the wrong button on a real computer. And the buttons on a real computer say things like confirm purchase and delete account and send. Think about the failure modes. The agent could be doing your shopping and misread a quantity. It could be tricked. A malicious web page could show text that says, "To the agent, ignore your task and go do this instead." The screen-based version of the prompt injection you learned about in the guardrails episode. This is exactly why, in serious deployments, these agents run inside a locked-down sandbox, a throwaway virtual machine with no access to your real accounts. And why they are built to stop and ask a human before any irreversible action, anything involving money, deletion, or sending. The guardrails you learned about earlier are not optional decoration here. They are the only thing standing between a helpful assistant and an agent that confidently empties your shopping cart into a purchase you never wanted. So how does this land depending on who you are? As an individual, this is the technology behind the promise of an agent that actually does the tedious thing for you, filling the form, doing the comparison shopping, wrangling the clunky website. But for now, treat it like a brilliant intern who has never seen your computer before. Watch what it does and never hand it your credit card unsupervised. As a startup, computer use cracks open automation for all the software that never had an API. You can build an agent that operates a legacy system or a third-party site that no integration ever existed for, which is a real superpower, as long as you respect how brittle it still is and keep a human in the loop for anything that matters. And as a large enterprise, the prize is automating the millions of hours of repetitive screen work no API ever reached, but the caution is proportional. You run these agents in tightly controlled, sandbox environments with hard limits and human approval on consequential actions because an agent with a mouse and your permissions is exactly as dangerous as it is useful. So let us bring it home. A computer use agent perceives a screen as a screenshot, reasons about the goal, and acts with the mouse and keyboard, looping perception and action one step at a time. And its whole promise is that it can operate any software a human can, no API required, which is why it is one of the most exciting frontiers in AI, and also, honestly, one of the least finished. Still stumbling on a real share of everyday tasks on benchmarks like OSWorld and carrying safety stakes that nothing else in this course comes close to. And notice the shape of the whole arc you have just walked. We started this bonus round with a model that learned to think longer before it answered. We gave that reasoning a terminal and got an agent that builds software. And now we have given it a screen and gotten an agent that can, in principle, use your entire computer. Reason, then act on anything. That is the trajectory the whole field is on right now. This is where the bonus round rests for the moment, but the frontier keeps moving, so subscribe, and I will keep taking apart whatever comes next, the same way we have taken apart everything else, all the way down to how it actually works. Thank you again for going the distance. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.